Hey guys, welcome back. Today I want to talk a little bit. I want to finish reviewing our special right triangles, our 30, 60, 90s, and our 45, 45, 90s. But I also want to take a moment and I want to start looking at the sine, cosine, tangent, trigonometric ratios. Things that we're going to be continuing to look at, things that you guys are going to work with a lot in the future. All right, so to start off, I kind of changed policy up a little bit. I'm not going to do necessarily the warm-ups anymore, but what I'm going to do is I'm going to do different examples for you guys to kind of see. And the first one here is we have a 30, 60, 90 on this side. So with that 30, 60, 90 on this side, all right, we have a ratio of 1 to the square root of 3 to 2. And you guys can go through, and I like to label these things. This is my square root of 3 side, this is my 2 side, and this is my 1 side. So what I have to do now to figure out the other side here is I have to take 5 square root of 3 over 3 and multiply it by the square root of 3. And I like to put it over 1 so I can kind of see, and I get 3 over, well, the square root of 3 times square root of 3 is going to be there, 15 over 5. I get 5 for this side here. All right, and now all I have to do is double this, so I get 5 square root of 3 over 3 times 2, and I like to do the over 1 so I can see it. All right, 3 10 square root of 3. Well, that simplifies out to, well, basically that. So that is your hypotenuse right here. And it's as simple as it is. It's just applying those ratios that we've looked at. Now looking at this other side, I know this is a 45, 45, 90, right? And I know that this is my square root of 2 side, and this ratio, these are 1s. Well, because I have that, well, basically going to go from the hypotenuse to the leg here by dividing by 2. And I can't really do that. That's not the simplest form. So I'm going to multiply by the square root of 2 over square root of 2. I get 4 over 2 times the square root of 2 up here. These cancel out, and I get 2 square root of 2 as my sides. So 2 square root of 2 as my one side here, and I am done. So that's basically how you do it. Now, it's a proportion review here. It's going to be that distributive property that we've worked with so much. All right, and as I set this problem up, you guys can probably work through it and see I get 6n minus 12 equals 4n plus 4. Now what I would do in this situation is I would add 12 to both sides. All right, so I add 12 to both sides here. I get 6n equals 4n plus 16, subtract 4n from both sides, and I get 2n equals 16. N equals 8. Two ways to do it. You can work with the negatives or you can do it this way. It doesn't matter. Both come out to the same answer. So let's talk some trigonomic ratios. When we talk about trigonomic ratios, we're talking about our sines, our cosines, and our tangents, but it's really important that we review the important information for us to understand exactly where things go in these. So we have a hypotenuse, which is always going to be the longest side, and it's always going to be opposite that right angle, which isn't on this diagram, but it is safe to assume that that's a right angle if we're talking about trigonomic ratios. So there's that box there in that corner. And what you can see is that this is opposite. And then we're going to have the legs that are going to be adjacent to it. So adjacent to the right angle and adjacent to the right angle. And because those are adjacent there, it makes it so that it's a lot easier for us to kind of see as we start going through. All right. So here is exactly what your trigonometry ratios are. Your sine is going to be the side opposite the angle over the hypotenuse. The cosine is going to be the side adjacent to the angle over the hypotenuse. And tangent is going to be the opposite side over the adjacent side without the hypotenuse. Right? I like to look at it in a little more simplified terms, something like this. And I like to remember this short saying as I do. I like to think of GL-Soh-Cah-Toa as a way of doing it. Now, my high school teacher used Indian phrasing like this all the time, and it was probably slightly offensive, but he was old, so we kind of let him do it. All right, but what we definitely see is we see this idea happening here where this is basically a mnemonic device to help us remember. So we see, for instance, we see sine opposite over hypot, right? Cosine adjacent over hypot. And then we see the tangent, all right, opposite over adjacent. All right, and that's just a simple way for us to kind of remember how to go about and solve these. So here are some 3 problems I want you guys to pause and practice on your own, and I'm going to go over each one in just a moment. So now that you guys have had a chance to practice it and use your Soh-Cah-Toa, what I will say is that I want to show you exactly how to do it. So this is a sine problem here, which means that we're going to use the SO part. We're going to take the opposite side of angle X. Here's angle X, right? So we're going to take the 40, and we're going to put it over the hypotenuse, which is 41. I'm done. That's it. It's there. I can plug it into a calculator and I can get a decimal, but this form is absolutely 100% correct. Looking at the next one, it's a cosine problem, which means that we are going to deal with our ka part. All right, so we're going cosine A, so we need the adjacent side of A over the hypotenuse. Adjacent, 7 over the hypotenuse, 25. I cannot simplify that. I am done once again. Last but not least, let's look at the tangent, which is the TOA part of our examples here today. And what you will see is you will going tangent to x. So the adjacent is here, and our opposite is here. So it's opposite 9 over, ooh, I did that wrong. It's going to be that 40. That's the adjacent side, not that. Anyways, that would be your final answer here as well. So with that, that's our basic trigonometry functions that I want you guys to practice. All right, so when we talk about sine, cosine, and tangent, remember the phrase Soh-Cah-Toa. All right, and when we think of Soh-Cah-Toa, what we start to see is this idea of having a situation that we apply it to. So thanks for watching. Take care. Have a good one. I will see you guys in class.